more colors than an Amiga on your Commodore 64? Well, sort of. In this video, we'll take a look at some of the cool tricks you can do with the color palette on the Sysop-64. But first, I want to give a big shout out to the Sysop-64 alpha testers. Your feedback is helping shape the direction of this project, and I cannot thank you all enough, so cheers and keep the feedback coming. Alright, let's dive in. In this video, I'm using the November 2nd build of the FPGA core, as you can see by the output of the cmds command here. Remember in a previous video I showed you how to change the C64 color palette using the setColor command. In this first demo, we'll use a new HDMI command queue to change the entire 16-color palette on every C64 screen row. We just build a table of colors and use a couple of APIs to wait for specific HDMI lines and then change the RGB value of each of the 16 colors in the palette. Let's try another one. For demo number 2, we'll change on every HDMI line and add some color cycling while we're at it. Or how about this one, where we cycle the background and border color? Speaking of the borders, the latest FPGA core adds a new ability to set the color of the extended border area. That is, the left and right borders that fall outside the range of the Commodore 64's video. In demo number 4, we're assigning a random RGB value that is totally independent of the C64's color palette. In demo number 5, we use another mode which sets the extended border color to an index into the C64's 16-color palette. And here's an example of cycling the background and border with the extended borders enabled. It can be kind of entertaining to run this while running some of your old C64 games or demos like this one. Anytime you need to reset colors back to the default palette and extended border mode, just use CMD20. Let's try a couple more. How about this animated checkerboard effect? In this next one, some simple bouncing bars. Let's try something practical. A simple technique used on the Amiga is changing the color palette on different lines to allow more colors on screen at once. International Karate, also known as chop and drop, used this technique. As you can see here on the C64, the colors are a bit limiting. For example, the same color is used for the sky in the background as well as the skin color of the players. If I run the HDMI colors demo in chop and drop mode, it's modifying the color palette in the lower half of the screen. Notice the skin color is no longer the same pinkish hue used in the sky color. I'm also cycling through random color karate suits for the other two players just for fun. The code to do this is simple. We just send commands in a loop to the HDMI command channel, telling it to wait for line 580 and set new RGB values for the 3 colors we're changing. Then do the same for line 1, but change them back to their default values. Sysop-64's FPGA has a dedicated HDMI command queue, separate from the DMA FIFO and everything else. And finally, there's another new capability that the latest FPGA core adds, and that's the ability to push the frame buffer behind the Commodore 64's video. Let me show you what I mean. Now let's put a picture on the screen using ShowPic. In this case, the Sysop-64 logo that is shown when you hit buttons 2 and 3 together. If I issue Command 30 using CMD, we change the rendering order, and the frame buffer is now sitting below the C64's video. In order to see it, we need to make one of the Commodore 64's colors transparent. In this case, I'll use Set Color to set color 0 to transparent. Now, if I change my color to black and turn on reverse mode, you can see the picture appear underneath. Let's change the border color with a poke command, and also turn on our extended border to see more of the image. Note that right now there's no real alpha blending support. It's either on or off. There's much more to come with Sysop-64, so please like this video and subscribe to support this project. Thanks for watching. See you next time.
I'm coming for you.